In the last module, we looked at simple forecasting. We're going to continue by looking at a related topic, which is called linear regression and correlation. Linear regression is a method of finding the equation, in this case a linear equation, that comes closest to fitting a collection of data points. So we saw from the previous example, from the last module, let's take a look at it, that we had these data points. We did see from all the data over here that we used this least squares method of getting a linear equation, and the equation is y equals 1.4x plus 2.8. And just to review that, what this basically means is if we do not advertise at all, then we can expect sales of 2.8. If we advertise one time, then sales would be 1.4 times 1 plus 2.8. That would be our forecast based on this linear equation. In general, a linear equation has the form of y equals a plus bx. And I'll just put that on the screen so we can see that. Y equals a plus bx, where x is called the explanatory variable and y is the dependent variable. The slope of the line is b, and a is the intercept of the value of y when x is 0. Now, if we're going to be looking at linear regression, we should understand that linear regression attempts to model the relationship between two variables, and these are the two variables, namely advertising and sales. Other examples, before we proceed, could be we may want to relate the weights of individuals to their heights, and we can gather the data and possibly create a linear regression, a straight line which would show possibly that one weighs more, he's taller. Is that possible? Or if one is taller, he weighs more. So these are things that who knows if that's true or not, and maybe it doesn't even make sense. And that's why before attempting to fit a linear model to observed data, we should first determine whether or not there is a relationship between the variables of interest. And this does not imply that one variable causes the other. For example, higher SAT scores do not cause higher college grades, but there is some significant association between the two variables. So, in our last module, which we see right here, we drew a scatter plot. And this scatter plot, this line, these dots over here, can be helpful in determining the strength of the relationship between the two variables. And we did see that advertising did seem to help as far as the sales went. So what we want to do at this point is, first of all, point out that we utilize regression analysis, linear regression, in order to obtain this line. And now we would like to determine what's called correlation. A valuable numerical measure of association between two variables is what's called the correlation coefficient. This value varies between -1 and +1, and this indicates the strength of the association of the observed data for the two variables. So in our case, since the line goes very close to those dots, we would expect that the correlation coefficient should be up there close to 1. And the difference between close to 1 or close to -1 is just dependent on the slope of the line. Just one is positive, one is negative. But if we obtain a correlation of +1, that would mean that all of the dots are on a straight line. And if the slope were in the other direction, negatively, and they're all on the straight line, then R would be -1. So let's obtain the correlation coefficient for this. To do that, we can just click on the line, and we are going to right click, go down to format, click on it, and we're going to go down to format trend line. Now we have choice display R square value on chart. That refers to what we're trying to obtain, namely the correlation. Now let's take a look. Let's bring this over and see what we have. We have an R square value of 0.8448. Now, mathematically speaking, R square and R are different terms. R square stands for what is called the coefficient of determination. We are going to be interested really in the value for R, so we need to take the square root of that. And if we did that, we would find out that R, the correlation coefficient, is about 0.91. Now, 0.91 is a very significant result. And that is a measure, again, of how well the trend in the predicted values follow the trends in the past actual values. It's a measure of how well the predicted values from a forecast model fit with the real-life data. So the value is relatively close to 1, which means there is a significant relationship between the two variables, namely between the amount of advertising and the amount of sales. As the strength of the relationship between the predicted values and the actual values increases, so does the correlation coefficient. We cannot expect a coefficient to be greater than 1, but in general, the higher the correlation coefficient, the better it is. I should point out that we can obtain the correlation coefficient a different way using the add-ons in Excel. What we need to do is just highlight the data we're looking to create this correlation coefficient for. We go to data analysis, and we go to correlation. And we can click on that, say OK, and we have to define again where our data is, A2 up to B6 in this case, and let's click OK, and there we are. So that's what I was telling you earlier, that the correlation coefficient is 0.9 over 0.91. Here it's 0.92 exactly. Let's point out one final way of obtaining this information. We can go to data analysis again, and this time we can choose regression, and I can click OK, and we define where my Y value is, where my X value is, and where I'd like to put the results. And as you can see, there are other items here which we are not looking at. Let's click on OK, and we see a lot of data, but let's just point out two things from here. Number one, we have two things we know from before, namely the R value, it's called multiple R, 0.92, that's what we just found, the correlation coefficient, and the R square value is the coefficient of determination, which is 0.84. Even though we're not going beyond this point, but the table down here indicates how significant is our result. In other words, is the trend line really significant? Does it really show there is a good correlation? Well, this number over here, 0.02, the closer this is to 0, the more significant is our result. And this is another way of looking at the result of the statistics, seeing that yes, it is significant, and I should pursue more analysis with the particular data. So in sum, we see that regression analysis is widely used in forecasting. It's also used in understanding which among the independent variable is related to the dependent variable, and for us to explore the form of this relationship.